Alrighty, guys. Good morning and welcome back again to Prop Stats. Today, as you probably noticed, you got a sub. I've got to take my dog to the vet. We recently adopted a little lab, just about like 40 pounds, and we're just making sure that she's doing okay. She just transitions in the house, so nothing major, but definitely going to be gone for probably the day. In the meantime, it's a nice, easy work day for the most part. Just wrapping up some of the SPP assignments, getting classwork submitted. And moving into phases 3 and 4 of the data project. So now that we have some survey data results, actually getting into the analysis, getting things set up in such a way that we can construct our confidence intervals and start moving into the deeper end of the pool there with the project. So for our time today, I'm going to just get you through the data that you need for that second part of the pre-work problems. The last time that we met, we talked about a warm-up with proportions. This one we're going to tackle with means. In particular, we're going to use some data from our actual results from the seniors and the number of hours that they worked. So what I'm going to do is get that slide up here. The one I want to take a look at is here in the pre-work document. Mr. Hunt, has noticed over the years that many of his students have part-time jobs while finishing high school. He suspects that among all seniors at Eagle Crest, the average number of hours worked per week is approximately 16. And I'm looking to construct a 90% confidence interval for the true mean hours worked per week by seniors at our high school. So to kind of open things up, what I want you to think about with your group mates here is what is it that we're trying to estimate? What's the level of confidence? So we start with the state step. Then we're going to launch into the plan stage, and we're going to talk a little bit about the details of this. So how do we know, for example, that we're going to argue that this is a random sample? How is it that we might be able to structure an argument that we have independence? And how is it that we might structure an argument for approximate normality? So I want you to maybe pause the video there for a few minutes and try giving that a quick think. Real quick with your group mates, just chat this one over. What is it that we're trying to estimate here? What's the level of confidence that we're working at? And how are we going to move through some of the plan stages there? How are we going to hit these different conditions? We'll go from there. All right. So as we wrap this one up and we start thinking about how to start posing this problem, right? First thing we always do with the confidence interval, we always talk about what it is we're trying to measure. Based off some of the feedback from the quiz, I would definitely say on this one, we're still kind of wrapping up some of the final thoughts, right? So what I'm going to do is kind of hit different elements that you're going to see that could be part of this answer. And what we're going to think about is the population that we're working with and the sample that we happen to draw. We're going to think about what the parameter is and what the statistic is. So in statistics, when we talk about parameters and samples, when we talk about populations and statistics, one of the things that we often want to think about is who or what is it that we're trying to describe by taking a smaller sample, and what is it about the population that we're going to be able to describe in that way. So for our particular scenario, we're trying to figure something about all Eagle Crest High School seniors, right? So for the population, I might say all EHS seniors. Now, I can't talk to all of them. So what I did is took a sample of some of them that I had here in my 1A and my 3A class that were willing to complete the data survey. Now, in particular, I think we've got something like 21 seniors that completed that. I think in total we have 35 participants. Some of those are juniors, some of those are sophomores. Most of them are seniors from Prop Stats, though. So I'm trying to draw a conclusion about all seniors at Eagle Crest from this really limited group of only 21. So I got to kind of take this estimate with a grain of salt, right? That sample might be all sorts of different problems, all sorts of interested biases. It's definitely not a random sample that we got from our survey if we only talk to the people that are in our Prop Stats classes, but it is a sample from the population. Now, the parameter that I'm trying to estimate is the true average number of hours worked by all seniors at Eagle Crest High School. I have no idea what the value of that parameter is, but what I'm going to do is generate a statistic on our sample. So if I want to estimate that parameter, I'm going to try and figure out X bar, the average of just our sample. So I'll take the 21 responses to the survey, and I'll average out the number of hours that they worked. I'm going to use that to give me my best available guess at what I think the true parameter might be. Now, I could be wrong, and maybe a different interval could be right, but that's going to be the best available estimate that we have. And we're going to do this at the 90% confidence level. So when they want us to define the parameter, what it is we have to talk about here is that we're looking for an average for the whole population. When we're talking about confidence level, we're going to specify the level of long run error or long run accuracy we're willing to tolerate to maybe get some level of precision on this interval to give us kind of a narrower window on what's happening. Now, once we get to the second phase of this, when we're starting to talk about the plan stage, there's always three things that we want to talk about. First thing is you want a random sample. Obviously, our group of seniors is not necessarily a random sample. If we think about survey results, only the people who feel motivated to respond to the survey are going to respond in the first place. And surveys historically have very low participation rates. It's really natural and normal for these types of things that you don't get all the data out of all the people that you gave it to. Even when I gave it to some of my junior classes, I had very few people that wanted to add their data into the set. So that's why we only got like 35 responses total, right? So this condition is almost always one we want to guarantee. If you can't guarantee a random sample, you should be very, very hesitant to construct a confidence interval in the first place. If you don't have a random sample, you could have potentially massive bias problems in your sample that you collected, which are going to vastly skew your estimates and throw your confidence interval off. So this is a bad idea to build it based off of our non-random sample. We're going to build it anyway, just for the practice of it. Even if we have it, we're going to have to take it with a grain of salt for this condition right off the bat. Now, the next one is independence. For independence, there's a few different ways to think about this. Kind of the really down-to-earth way of thinking about it is if I were to draw my sample of 21 seniors from the full population, is it likely that by drawing the seniors that I've got, it's going to influence the next senior that I could have drawn's answer to the number of hours that they worked? And the answer to that's probably no, right? It's going to be pretty rare that if I collect a group of seniors that their responses are going to change the next one that I'm going to get in the sample. And it has a lot to do with probability, right? Now, it's only a fixed number of seniors in the building. So if I get all the people who work the low hours and it's only the people with high hours left and I draw one more, well, of course, I'm going to have a higher likelihood of drawing someone with higher hours. So there's always a little bit of an argument that can be made there that you're always shifting these probabilities minutely. But the way around that is essentially to argue that whatever sample you draw is a very small handful of a very big bin, like we saw with the green Skittles activity back for the binomial distribution. So the rule of thumb there is if your sample is less than or equal to 10% of the full population, and we usually write that with this inequality. Little n is less than or equal to 0.1 of big N, where big N is the full population, you're good to go. So as long as the sample is less than 10% of your group, you're not really shifting those probabilities all that much, and you're good to go. Kind of a more down-to-earth way of thinking about that is one person being included in the sample going to vastly change the likelihood of drawing someone different if you were to continue going. And in that case, we're not really going to be able to make that argument. So we don't really have a random sample. We've definitely got a sample that's probably going to meet this independence criteria. And then we got to get approximate normality, right? And this is where it gets a little more interesting. You can make the argument that you're going to get an approximately normal sample distribution. So your handful of seniors is going to have maybe that kind of bell curve distribution. If you meet certain conditions, and I'll go from maybe the strongest conditions to the weakest at the bottom. The best condition is that you know for a fact that your sample is pulled from a population that really is normally distributed. So I might write that as population normally distributed and put a question mark on it, right? If my population of seniors and their hours worked per week is a perfect bell curve, I've got a pretty reasonable hunch that if I take a sample out of that, I got a good chance of seeing that same shape in the sample. It's not going to be perfect, and there'll probably be a little skew one way or the other, but if I were to increase the sample size, I get better and better approximations, right? So if your population is normally distributed, that's usually all you have to write. We don't necessarily know that that's true for all seniors at Eagle Crest. There might be a big skew one way or the other because we've never really studied that, right? So I don't necessarily want to go that route with the argument. The other thing that I can say is if my sample size is greater than or equal to 30, then that's maybe the next best thing for the argument. So maybe that population isn't really normally distributed, but my sample is going to have a better chance of having that kind of bell curve shape if my sample size is at least 30 items. Now, what we're going to see in our sample is that we've only got 21 seniors, and 21 is not greater than or equal to 30. So that condition's kind of out too. The last thing that we might be able to argue is whether or not the data set in the sample is symmetric, or at the very least that there's no outliers. This is kind of the weakest argument we could make in this scenario, but this might be the only one that's possible. Now, what I'm going to do is maybe throw the data into Staplet real quick so that we can take a look at it, and we'll see if we can make this argument based off of the data that we've collected so far. All right, so here's what I've done so far. I've taken all the data that we got in our survey spreadsheet, and you can kind of go and look at this data yourself. It's posted there under the Unit 6 folder, Lesson 6.4 in Schoology. I've just thrown it in a Staplet to see what I got in my sample. Right off the bat, you're going to notice a bit of a problem here. If you take a look at the distribution of, say, the hours worked per week on average for Eagle Crest High School seniors, the most common result is 0. And it looks like approximately half of our data, maybe just shy of half of our data, has seniors working 0 hours per week. And then there's a little bit of a distribution far to the right of that. And we even got one survey response there, something along the lines of 38 hours per week. Wow, that's a lot of time, especially when you're right in the middle of finishing up your senior year of high school here. So if we're taking a look at Staplet here, and I could shift this around to look at some different displays of the data, we're seeing a skew problem and we're seeing a lot of outliers. So this is going to be a really bad idea to try and build a confidence interval around this. When you do build a confidence interval and you introduce that margin of error, you need your data to be roughly symmetric because you want to give or take the same amount on either side of your point estimate. This is a terrible idea because what we're going to see here is that the data is really lopsided on one side and going to be really, really narrow on the other. So even if I could build a confidence interval here, its validity is going to be pretty weak. So we got to be really cautious about how far we take our understanding of what's going on here. Now, I'll do the calculation just so we get the reps in. Again, we're going to have to take this with a lot of grains of salt here. This is not necessarily something we should put a lot of faith in. Now, what we're going to do is we're going to take that data, we're going to calculate the summary statistics, so the average, the sample standard deviation, the sample size. We're going to find our t-score, and we're going to run the 90% confidence interval. In the data from the survey, you'll notice that there were a handful of responses in which people gave a range of values, which is not what they were supposed to do. So what I did, if I was given a range of values, is either find the halfway point, kind of the middle of the range, or if it was like between one or the other, I chose the low end estimate. So I've done a little data cleaning to get this particular data set. You might clean it a different way between you and your group mates, especially as you get in the project. So there's not always just one right way to do it. For this particular set of data, what I'm going to do is show you how to use the graphing calculator to calculate your t-distribution and get your summary stats, just so we get flexible ways of working with the technology here. So I'm going to switch screens real quick to my TI-83, TI-84, and all I've done so far is just entered the data into the calculator. In order to give the calculator your data, you're going to hit the stat button here, and then you're going to go to edit, and you're going to put all your data in one of these lists. I usually recommend L1 because that's the one it defaults to, but you can have multiple lists going at the same time and then specify which one you want to calculate your stats for. So once you enter all your data into this L1 column, the next thing we're going to do is hit second mode to the quit menu and go back to the home screen. Here, we want to calculate the one variable statistics because we're only measuring one variable here, the hours worked per week. So I'm going to hit stat, and I'm going to go over to calc, and I'm going to go to that one variable stats option, and I want to use this function on the list L1. So I'm going to hit calculate, and it's going to give me all my statistics that I need here. I've got my X bar, so my average there is about 8.76. And I'll write this down probably because I'm going to need to hold on to that. So my X bar here, about 8.76, and our sample sample standard deviation, that S sub X term, is about 10.91. So it looks like the average hours worked for seniors per week is maybe just shy of 9 hours, give or take, almost 11. Our sample is size 21, so that's the N term. I'm going to need that too. But then I've got to get my T distribution. So where I've got to be careful here is the level of confidence is going to play a big part in exactly how I choose that value. Now, you could use a table of values. In the back of the notes, there's that table B. It works just fine. I'm going to reinforce how to find it using the inverse T distribution here in the calculator. One thing that we have to be careful about is when you're talking about the T distribution, I'll go maybe to Staplet.com one more time, and then the T distribution calculator. You have to be careful on how you're going to make the argument that you get 90% confidence packed in the center. Now, one thing you'll notice with the T distribution is that if the degrees of freedom are low, it doesn't look much like a normal curve. It's much wider. But as your degrees of freedom increase, and that's always the sample size minus 1, so in our case, it's going to be degrees of freedom is 20, you get closer and closer to a normal curve. So the more things you have in the sample, the higher your degrees of freedom is going to be, the more normal the data is going to look. All these things are good in the long run. What we want to do is we want to find the area or a value corresponding to an area, right? What I'm going to do is change this maybe to a central test where I want 90% of the data packed in the middle. So the way that we're going to think about this is if there's 90% of the data in the center, there's going to be 10% on the edges, which means I need 5% and 5% in each tail. And thinking about that mental math is really important to get your inverse T distribution correct when you're working through these kinds of questions. So you always want to think about one tail, one side of this distribution. If there's 10% to spare for both, I've got 5% in just one of them. Once I know that, I'm now ready to take my calculator and find the inverse T distribution to get the exact T value for our data set. The way to do that is go second mode to quit to the main menu, and then we're going to go second vars to the distribution menu. Under the distribution menu, we're going to go to option 4 for inverse T, and I'm going to specify that area in one tail of the test. Now, 5% is the decimal 0.05. My degrees of freedom here are 20. All I've got to do is just let the calculator paste it in the main screen, and I got my T-score there. It doesn't matter if it's positive or negative because we're really going to need both of them. I'm going to see here that my T-score is approximately 1.725 roughly. 1.7, I'll round that maybe to 1.73. That'll work just fine, I think. So in this particular instance, I've got my T-score, got my sample average, I've got my standard deviation, I've got my sample size. So we've got everything that we need in order to wrap this problem up. So I'm going to use my formula, and I'm essentially just going to start doing my number crunching, right? And take this one small step at a time. We know for our formula that the confidence interval is going to be your sample average plus or minus your T-score times your standard error term, and that's the sample standard deviation divided by the square root of n, your sample size. Our sample average here was 8.76. We're going to go plus or minus our T-score, which is about 1.73, and then we're going to multiply it by the standard error. So the sample standard deviation, 10.91, divided by the square root of 21. So once we do the number crunching here, once we actually get this guy kind of hammered out, we'll see this point estimate, 8.76, and then we'll get that margin of error kind of on the other side there. Now, all we want to do is just take it one small step at a time in the parentheses first. So what I might do is 10.91 divided by the square root of 21. And I'm going to get about 2.381 there. I'm going to take that value, I'm going to multiply it by 1.73. You can think of in that T distribution, the 1.73 is how far away from center you got to go in terms of standard deviations to get 90% of the data packed in the middle there and 5% on each edge. What I'm going to get out of that is about 4.12. So my margin of error here, this kind of plus minus part of the equation here, is telling me that give or take roughly 4 hours around this average of 8.76, my point estimate, that's our confidence interval. That's our best estimate for the true actual count of hours per week the seniors in our school work. Now, if I wanted to find the high end of that estimate, I could do 8.76 plus 4.12. I'm going to see on the high end of my estimate, it could be as high as 12.88 hours. On the low estimate, I'm going to do 8.76 minus 4.12. I'm going to see on my low end, maybe 4.64 hours. So from there, my best guess at this level of confidence is that maybe the true value is hiding in there. Now, at 90% confidence, what that means is if I were to do this 100 different times, get 100 different samples of seniors, and calculate 100 different confidence intervals, none of which agreed with each other, about 90 out of 100 in the long run are going to get it. There's a lot of problems with the setup on this, though. Our sample's not really random, and our data is not really symmetric. And we're playing with it as if it is when we build these kinds of confidence intervals. So we got to take this result with a grain of salt. Because that sample is so badly skewed and because it's from survey data, so it's kind of a convenient sample, we don't necessarily trust this to be a fair, representative, accurate read for how this measure really stands up for all seniors at our school. But that's how you calculate it. That's how you actually run this thing out. So I wanted to make sure, kind of hit that one there as we wrap things up for our SPP assignments and start getting into our data project. For those of you guys that need to do a Unit 6 quiz, retake, or makeup, you're welcome to request them in the Google form that we got on Schoology. My goal is to have those probably ready by Wednesday morning there, especially for those of you guys that are requesting them today. Those are going to be due probably March the 14th, this Friday, before we leave for spring break. When we come back after the break, we're going to start diving into inference with hypothesis testing. So kind of the other side of the coin, the confidence intervals. While you've got the sub here, you should have your phones away during class. You don't need it for classwork. You don't need to submit any classwork. Don't need them for any reason. You got Staple on your computers, you got graphing calculators. So make sure that you get your phones away while the sub's there. If there's an issue, they'll take a note of it and let me know. Otherwise, as we go from here, we're going to get everything knocked out as far as our classwork, our SPP, and our projects by Friday before we leave for the break. So you should be finalizing all the classwork assignments with your group mates. You should be well into the process of working on your data project. So everyone's got survey data. What I might do real quick is share with you guys on Schoology where you can find that, just to double check that everyone knows where to get it. So if you want to find that data, the way to do it is to go to our ProbStats course, and then here under semester 2, and then the Unit 6 folder, you'll find it down here at the bottom. It's going to be the Unit 6 Data Project Survey Results link. You're going to get a view-only version of the spreadsheet. So if you go File, Make a Copy, you'll get your own that you can clean and edit and delete everything that's not relevant to you and your group mates to form your data set for the project, which should definitely be a component of your submittable, regardless of the format that it's in. So that's where you can access the data. Like I said, we got about 35 responses, which is not bad. There's a nice mix of juniors and seniors, a handful of sophomores. So lots of interesting questions coming up in that process. If you don't want to work with the survey data, you can definitely use a randomized data set, like something from Census at School. You could generate your own, or you could use the one that I pulled from there, which is all about hundreds, I think, of high school students here in the state of Colorado. All sorts of interesting survey questions were a component of that. Yeah, we got spring break coming up next week. So we're going to start wrapping things up for Unit 6 here. We're going to get our quiz retakes and makeups knocked out. We're going to finish out the classwork, the SPP, get the project done. Today, you guys are just working with your group mates to kind of finalize the efforts to build out these confidence intervals for some of these different projects and the topics that you guys are working with. Here in the slide deck, which you'll also find linked up in that lesson 6.4 folder, you'll find some useful reference materials that we've been building on in the notes. We know that confidence intervals are a way of estimating something when we don't really know what the value is. And we know the level of confidence is the long run success rate of lots of different intervals that we construct. We've seen confidence intervals for proportions, for when it's either one thing or the other, yes or no. It's very binary outcomes. And we've also seen confidence intervals for averages, where instead of yes or no, it's like this range of values, but there's a center to it. And we're thinking in terms of standard deviations. The conditions that you need to check on each of these are going to be different. For proportions, you can use a z-score, whereas with an average, you got to use a t-score. For approximate normality with proportions, you can use the large counts condition, which I think a few people were trying to use on the quiz. not necessarily the condition we want to check when you're thinking, say, for an average. For averages, things get a little different. It's kind of more of an open-ended conversation when you're talking approximate normality. The strongest argument that you can make is the population is normally distributed. So that means your sample stands a good chance of being normally distributed. The next best thing that you could say is that your sample size is greater than 30 and it's less than 10% of the population. So you have that independence check going well. You got a sample that's going to be starting to look kind of bell curved if it's greater than 30. But if you don't know it's from a normal population and you're working with a small sample, which is why we use these t-scores in the first place, you definitely want to at least try to make the argument that your data set is symmetric and doesn't have any outliers. Like we saw in our SPP warm-up there, or rather our pre-work warm-up, we had a data set that was highly skewed, and sometimes that happens. In those instances, we usually don't want to build confidence intervals. For the sake of the project, we will do it anyway, even though we might need to take it with a grain of salt. So these are some useful things that might help you guys as you're kind of working through the process. Like I said, these class slides are available on Schoology, so you can go digging around in them for the lesson 6.4 folder. Lots of good reference materials. If you guys have any questions, I'll be back on Thursday. So we'll kind of touch base and see how things are wrapping up in terms of final submissions and final touches on the analysis. But in the meantime, while you got the sub in the room, I want you guys to start finishing up your classwork, put your final touches on the SPP, and I want you guys to start moving through phases 3 and 4 of the project, so the actual analysis of the data. Other than that, I hope you guys have a great rest of your day. I'll see you guys again on Thursday, bright and early, or in the afternoon for my 3A crew. See you then.